Hello, and welcome to the next video in my series on finite mathematics. Now, a few things before we get going. Number one, if you're watching this video because you're having problems in a class right now, I want you to stay positive and keep your head up. If you're watching this video, it means you've come pretty far in your schooling already, and you may have just hit a rough patch. So, I know with the right amount of hard work, perseverance, and practice, you can get through it. I have faith in you, and so should you. Number two, please feel free to follow me here on YouTube and or on Twitter. That way when I upload a new video, you will know it. And three, just keep in mind that these videos are geared towards individuals who are relatively new to finite mathematics. So the example I will be using is very basic. However, I will be describing it in great detail, going very slowly, and explaining each step to you so you know exactly what's going on. So all that being said, let's go ahead and dive right in. Now this video is the next in a series on Markov chains. And in previous videos, I started at the very beginning and talked about what Markov chains are, how they're related to probability trees, and then we talked about transition diagrams, and then transition matrices, so on and so forth. So I am going to assume in this video you know the basics of what Markov chains are. If you're still unsure, please go back and watch that video and or look at your textbook and class notes so you have that basic understanding so you can understand this video. Now in the video right before this one, I did a one-step transition video. So this is just the next step. We're going to take the Markov chain one more step into the future, and then that will help us develop a general model or a general idea about Markov chains overall. So let's go ahead and look at our problem. So this is the same problem from the last video. I'm going to go through it very quickly. An automobile insurance company places its policyholders into one of two categories when the policy renews, and when they sign up for that matter, low risk or high risk. A motorist is high risk if that policyholder has received a ticket within the past 12 months. If they have not, then they are considered low risk. So ticket in the past year is high risk, no ticket in the past year is low risk. Now based on government data, we kind of estimate that any driver chosen at random, just out on the road, so you look over at the person next to you at the stoplight, we estimate there's a 10% chance that that driver next to you has had a ticket in the past 12 months. Now, of course, that means there's a 90% chance that they have not. So just based on different sources and the fact that people that get tickets tend to get multiple tickets, I just sort of estimated a 10% chance of having had a ticket and a 90% of having not had a ticket. So once someone comes into the insurance company, internal to the business, people can transition from high risk to low risk when their policy renews. So you can imagine if you're a driver and you have a lot of tickets or accidents, your insurance rate is probably going to go up when your policy renews. Same idea here. So if a policyholder is currently high risk, they have a 60% chance of being high risk again when their policy renews. Now, there's a 40% chance that they will be denoted low risk. So if someone's high risk now, there's a 60% chance they will have a ticket in the next 12 months and therefore be high risk when they renew. There's a 40% chance that they will not have a ticket over the next 12 months and will therefore be low risk. Now, if they're low risk now, so the top is if they're high risk now, so this one is if they're low risk now. If they're low risk now, there's a 15% chance that they will move to high risk when their policy renews. Another way of saying there's a 15% chance they will have a ticket in the next 12 months. Now, if they're low risk right now, then there's an 85% chance they will remain low risk and having not had a ticket in the 12 months ahead. So you can see the driver population within our insurance company seems to be a bit more riskier than the average population. So we may be a company that caters to drivers that find it hard to get insurance, either because of their driving record or something else like that, or they want lower coverage, whatever it might be. For this problem, it really doesn't matter. It just appears based on this data that our driving pool within our company is a little bit higher risk than the general population. And that's okay. There are many businesses that work with higher risk populations. So here's our question. If all of its new policyholders that walk in the door are representative of the driving population in general, what will be the company's high risk, low risk distribution or probabilities 1 year from now? So this is the one-step process, and then we'll do this and then build on it for the two-step. So here is our general driving population just out on the roads right now. There's a 10% chance a driver has had a ticket in the past year, so 0.1. There's a 90% chance they have not, that's 0.9. So ticket and no ticket. We call that the initial state. Now here's actually how to think about this in real terms. And the students I work with, I always try to put them mentally in a scenario where they can visualize it or relate it to their own experience. So the receptionist is sitting at the front desk of the insurance company. A random new customer walks in. Now based on the general data we have, there's a 10% chance that customer has had a ticket within the past year. And of course we get that from our general government data about the percentage of drivers having had a ticket over the past 12 months. So any random driver that wants insurance walks in the door, and based on just the data we have, the chance that they've had a ticket in the past 12 months is 0.1 or 10%. Now we call this the initial distribution. So this is the distribution we're starting with when someone walks in the front door to our insurance company. Now we can set up a probability tree, which I'm sure you've done in your finite class. At this point, it looks like this. So someone can walk into our office and be put in the high risk category because they've had a ticket in the past year. So that would be up in the state 1 box there on the top left. And then after 1 year, based on their driving record, their first year with us, they will be put back in high risk or low risk if they don't have a ticket. So it's just putting in a new category or a new step whenever their policy renews. And of course, the category they're put in is dependent on their driving history for the previous 12 months. Now, if they're low risk, they could go through the same process. They could come in low risk, not having had a ticket in the past year. When their policy renews 12 months from now, they could be put in high risk or low risk, depending on their driving habits their first year with our company. Now, when they walk through the door, they follow the probabilities of the general population. So this is our initial state. So this is sort of what walks through our door, and then we sign them up high risk or low risk depending on their 12 months driving history. Now, in the previous video, we figured out the probabilities for this for each outcome. So the probability that someone walks into our insurance company, they've had a ticket in the past 12 months, so they're high risk, that's 0.1. And then over the next 12 months, they have another ticket, so they're high risk again, that probability is 0.6. The probability of going through that path is 0.1 times 0.6, which is 0.06. And then we can do that for each path through the probability tree. So someone can come in and go high risk to high risk, they can come in and go high risk to low risk, or they come in low risk and they get a ticket, so they go high risk, or they come in low risk and stay low risk a year from now, and those are the probabilities there on the right. And of course, what do you think those probabilities add up to there on the right? They add up to 1, okay? So all of our probability has to be accounted for to add up to 1. So remember this from the previous video, we talked about a transition matrix. And this is what happens once customers are in our company. So this is a very straightforward transition matrix. On the left we have the from state, so they can come from high or low, then go to high or low. And here we just put in the probabilities that were from our tree. So the probability of going from high to high is 0.6, from high to low is 0.4, And notice those add up to 1. The probability of going from low risk to high risk is 0.15. From low risk to low risk is 0.85. This is just a different way of writing the exact same information from our tree. Then we have our initial state vector, which is our initial state distribution of 0.1 and 0.9. We've discussed that already. We can also write that as a matrix. So we call this the initial state vector, high and low again, same order. So 0.1 and 0.9 is the probability or the probabilities associated with the general driving population. Now, if we want to find the probabilities of high and low 1 year from now, we multiply those together. So we have our initial state vector, 0.1 and 0.9, multiply that by our transition matrix, and then we have the probabilities of high risk and low risk 1 year from now. And that's how it works, okay? So, if a customer walks in the door, after 1 year, the probability that he or she is high risk or low risk, respectively, is 0.195 and 0.805. And of course, those add up to 1. So, for one-step probabilities or one-step transition, our initial state vector multiplied by our transition matrix to get a new set of probabilities. Here it's 1.195 and 0.805. Now notice those are higher than the general population. So that's what we can say by the fact that our drivers and our insurance company tend to be higher risk than the general population at large. Okay, now let's talk about two steps. So all we do here is change one phrase at the end. So if all the new policyholders are represented by that 0.1 and 0.9 initial distribution, what will be the company's high risk, low risk distribution 2 years from now? So we just did 1 year. Now we want to look at 2 years. So we set up a probability tree the same way. So this is all the same that you've seen up to this point. Nothing new here. There we go. So that is the one-step process, the one step in this problem. So this is the same thing on the previous slide. But now we need to go another step. So from each one of these states at the end, the driver can go into high risk or low risk again the next year. So it looks like this. And again, we could do this for many years into the future, right? But the problem is this probability tree would become massive. It would be the size of a wall. So that's why we actually use Markov chains and transition matrices and things like that, because it allows us to do this far into the future without having to write a probability tree that is 8 feet wide. Now, of course, the probabilities here are all the same. And that's a feature of Markov processes in general, is that the probabilities from transitioning from state to state stay the same. So once a driver is in our insurance company, the probabilities of going from high to high or high to low or low to high or low to low remain constant over time. Now, of course, we can do the same multiplication process to find the probabilities of each path in the tree. So just to take one or two, for example, well, let's look at the top path through our tree. So someone walks into our office and signs up for insurance. Unfortunately, they've had a ticket in the past 12 months, so they're a high-risk driver. There's a 10% chance of that happening. Then they have insurance with us for the next year. Unfortunately, they have a ticket again, so they're put in high risk again. The probability of that happening is 0.6. So then over the next 12 months, they have a ticket again. So they're put in high risk again. The probability of that happening is 0.6. So to find the probability that someone comes in, is signed up as high risk, the next year they're high risk, the year after that they're high risk, that probability is 0.036, or 3.6%. See how this works? Now we could pick any other path. Let's go down to the bottom here. Let's say someone comes into our office and they're low risk. They have not had a ticket in the past year, so that probability is 0.9. Then over the next year, unfortunately, they do have a ticket. That probability is 0.15. But then over the next 12 months, they do not have a ticket. That probability is 0.4. So they get put back in low risk. So they come in or low risk, they get put in the high risk due to that ticket, and then the year after that, they go into low risk. So that is 0.9 times 0.15 times 0.4, which is 0.054 or 5.4%. So you should see how this process works. And again, this is 2 years from now, 2 steps into the future. And of course, those probabilities all add up to 1. Now this is simply a table version of that probability tree. So we have the now state, then we have the 1 year from now renewal state, and then the 2 years from now renewal state. And I've just used colors and letters to represent the high state, the high risk state, and the low risk state. So you should be able to look at this and tell, how I put it together based on the tree in the past slide. Sometimes this is just easier to work with when they become fairly complicated. Now what about a transition diagram? So they can come into our office and sign up for insurance having had a ticket in the past year or not. So this is 0.1 and 0.9 again. If they've had a ticket, they go into the high risk group. If they have not had a ticket, they go into the low risk group. Now if they go into the high risk, when they renew next year, the probability they're put back in the high risk is 0.6. The probability they go into low risk is 0.4. And again, those add up to 1. Now if they come in low risk, the probability of returning to low risk is 0.85, and the probability of going to high risk is 0.15. So this is a transition diagram for this whole process. And you can think of someone that's even with us for 5, 6, 7 years. They walk through the door, so they go down one of the arrows, they get put in high risk or low risk, and over the course of their career, driving career in our company, they transition through this process. So they could go from high risk to high risk to low risk to high risk to low risk, each step when their policy renews. This is a transition diagram. Now here is our one-step probabilities in terms of our initial state vector. They're on the left, the 0.1 and 0.9. And then we have our transition matrix there next to it. When we multiplied those together, we had 0.195 probability for high risk and a low risk probability of 0.805. So that's 1 year from now, 1 year into the future. So if a new customer walks in, the high risk, low risk probabilities are 0.195 and 0.805. We've already covered this. But what about 2 years from now? So 1 more year than this. Now what we can do is take the probabilities that we found after 1 year, and then we multiply that by the transition matrix again. So the answer from the 1 year step multiplied by the transition diagram gives us the probabilities after 2 years. So you can see here that our high risk group has a probability of 0.258, and our low risk probability is 0.742, and of course those add up to 1. Now in a practical sense, you can really see here just how much higher risk our drivers are than the general population. So a new driver comes into our office to sign up, and after 2 years, you can see the probability of being high risk is 0.258 versus 0.1 out in the general population. So again, we're just multiplying the result from one step, multiply it by the transition matrix to get the next step. Then we could multiply that by the transition matrix again to get the next step. You can see how that works. So if a new customer renews after 2 years, they've been with us for 2 years, the probability that he or she is high risk or low risk is 0.58 and 0.752 respectively. So that is our 2-step probabilities. Now there's another way of doing this, which we'll cover here in a minute or two. So what is the probability that a new customer will be in the high risk category 2 years from now? In other words, what paths in our probability tree end with a customer in the high risk category? So here we go. If you look on the right hand side, I have colored the high-risk states in bright red. So any path that ends high risk counts. Doesn't matter where they've come from before. All that matters is that they end in high risk. So we have the 1st, 3rd, 5th, and 7th in that column there on the right. These are our probabilities again. Now we're only interested in the probabilities associated with the high risk endpoints. So 0.036, 0.006, etc. So the question was, what's the probability that our new customer will be in the high risk category 2 years from now? Now, since all 4 paths are possible, all end at high risk, we just add those together. So if we add up the probabilities that have high risk as an endpoint, those tree paths, we have 0.23775. And again, that's just the summation of all the probabilities that ended at those bright red high risk points. So the probability that a new customer will be in the high risk state 2 years from now is 0.23775. Now, what about low risk? So this is just sort of the opposite of that. Which paths end with a customer in low risk? So I've colored those green. So we have 0.024, 0.034, 0.054, etc., down to 0.65025, which is the bottom one. Now we do the same process. All we have to do is add those together, and that is 0.76225. So the probability that a new customer that renews 2 years from now is in the low risk state is 0.76225. Now here's the shorter version. Now look at what this is here. On the left-hand side, we have our initial state vector. That is just the probabilities out in the general population. In the middle there, we have our transition matrix, which always stays the same. That's a transition from year to year regardless. And then the exponent for the transition matrix is the number of steps we're interested in from now. So this is our initial state vector times our transition matrix squared, because we're interested in 2 steps or 2 years into the future from now. Now when we do that, we add up, we come up with 0.23775 and 0.76225, which is the exact same thing we calculated when we did it by hand in our probability tree. Okay, so I kind of did it both ways so you can see where this actually comes from. You saw it very concretely in the probability tree, and here you actually see it in the matrix operations. Same thing, but of course when that exponent up there, say that exponent is not a 2, say that exponent is a 10. Do you really want to write a probability tree that has 10 steps in it? You know, again, it would be 8 feet wide when you write it all, and probably 8 feet tall if you try to write all that out. So it's just not practical, and that's where the Markov transition matrices come into play. All right, so let's go ahead and show you how to do this on the graphing calculator. Okay, so we need to go into the matrix menu in the calculator. So the first thing that we will do is hit the second button. We'll go down to matrix. Now we have to enter our matrices into the calculator. So we'll go over to edit. We'll select matrix A, hit enter. And our initial state vector is 1 row by 2 columns, so 1 by 2. And our values are 0.1 and 0.9. Hit enter. Now that is stored into the calculator as matrix A. But now we need to enter our transition matrix. So go back into the matrix menu, go to edit, select matrix B. Of course, this is a 2 by 2. And then we just enter our matrix into the fields. So 0.6, 0.4, 0.15, and 0.85. Okay, so now we have our initial state vector and our transition matrix stored into the calculator. So let's do the simple one first. Let's multiply the initial state vector times the transition matrix. That'll give us our one-step probabilities. So we'll go into matrix, select matrix A, times, go in, select matrix B, and that is 0.195 and 0.805. Remember, that's the exact same thing we found out when we did the one-step transition by hand in the tree. So let's go ahead and multiply that by the transition matrix again. So we'll go in, select matrix B, hit enter, and there that is, 0.23775 and 0.76225. So we took the answer from the one step and then multiplied it by the transition matrix again, and that gave us our two-step. Now let's do it the other way, using the exponents. So we'll go in, select our initial state vector again, so A times matrix B, which is our transition matrix, then we'll square it. Hit enter, and look at that, the exact same thing, 0.23775, 0.76225. So multiplying the one step of the transition gives you this answer, and using the exponents give you that answer. Okay, one final thing, and then we are done. So let's talk about what we would call a conditional probability. So it's sort of a question about a subset or a specific slice or part of our information. So here's a question. If a customer is placed in the high-risk category when they sign up, what is the probability that a customer will be high risk or low risk 2 years from now? So let's think about this in real-world terms. So the person walks into our insurance company and they talk to the receptionist that takes their information, and they had a ticket in the past 12 months, so they initially go into the high-risk category. Now, we tell them that, based on the information in the company, you have a so-and-so chance of being high risk 2 years from now, or a so-and-so chance or probability of being low risk 2 years from now. And we can actually tell them this information precisely using this Markov process system. Okay? So, we know the customer begins high risk. Now, look at the initial state there on the left. We have 1 and 0. Well, where does that come from? Well, what we know is that the customer, and this, by the way, is the answer for the high risk portion of this question, we know the customer's high risk. So we put a 1 in the high risk place. So of course we put 0 in the low risk place. Then we do the same process. We take our transition matrix and we square it because we're interested in 2 years from now. And then we actually find the solution to that. So in this case, if someone walks into our office and is placed high risk. Now another way of saying that, and this is how you'll hear it oftentimes in Finite, if not all the time, given that the customer is signed up high risk at the beginning, what is the probability that customer will be high risk 2 years from now? Conditional probability. So I'm sure you've heard phrases like that before, and this is exactly what it is. So this is one way to solve that. And I'm actually going to show you where these numbers come from in the tree in the next slide, and actually the last thing we're going to do. Now, if you wanted to do the low risk half of this, what would you do? Well, you would just flip the 1 and the 0. You put a 0 where the 1 is for high risk, and then you put a 1 where the 0 is for low risk. Then you do the exact same thing. Okay, so again, we're only interested if the customer comes in and is put in high risk. So we're not even worried about the bottom half. of the probability tree, because we're only worried about this top half. So given that they're high risk, when they sign up, what is the probability that they're high risk or low risk 2 years from now over there on the right? Now the first thing we want to do, and this, depending on your familiarity, this may seem obvious, but if we add up all those probabilities on the right-hand side, well, they add up to 0.1. And that should make sense, because look at our probability when we started. The probability they were high risk when they walked in was 0.1. So all we're kind of doing here is dividing that probability among different outcomes as the process goes on. So if we add up all these probabilities, it adds up to 0.1. Now let's say we're interested in the high risk ones. So the high risk there is 0.036 and 0.006. So if we add those together, we have 0.042. Those are the high risk. Now, the low risk, 0.024 and 0.034. That's 0.058. Now to figure out the probabilities, given that they started high risk, we just divide by the total probability at the end of those trees. So here, for high risk, we have 0.042 divided by 0.1, which is 0.42. And that's exactly what we found on the previous slide using the matrix. Now, same thing on this side. For low risk, we take 0.058 divided by 0.1, and that is 0.58, which again is exactly the same thing we found out on the previous slide. So if we have a question that says, given that the customer is high risk when they walk through the door, what is the probability they're high or low risk 2 years from now? Boom, this is it right here. You could do the tree if you want, or you could use the matrix method in the previous slide. So you can rewind and fast forward and look at the two to compare them. I think the matrix one is simpler, especially if you're using your graphing calculator, but you could do it with the probability tree too. Just remember, it's a conditional probability. Okay, so that wraps up our video on two-step Markov chains. So a few things just to set in your mind as far as what we've covered and what we're going to cover in the future. Well, number one, again, I just want to encourage you. If you're having problems in a class right now, I want you to stay positive. You are smart and talented and you've come far. So this rough patch is just temporary. Again, I have faith in you and so should you. And as far as Markov chains into the future, from now we've gone from the very basic building blocks up to two-step transitions. But the question then becomes, what if we're interested in this process 10 years into the future? Or even, 14 years into the future? What's going to happen to our probabilities? How can we figure that out? How can we model that into the future? And that's actually where we're going in the next part of this video, next part of this series of videos. I'm also going to try to do a few shorter videos of specific type problems, especially ones that are very practical, very real world, that you can actually get your mind around and your hands around and think about what it would look like in the actual real world. Now, a few more things and then we're done. Again, follow me on Twitter and or YouTube if you want to get new video notifications. I'm not selling or promoting anything but learning, so don't worry about getting spam or anything like that. I don't do that kind of stuff. And if you like this video, give it a thumbs up. Or if you think there are some things I could do better, leave a constructive comment below, and I will try to incorporate that into my future videos. So, all that being said, I want to thank you very much for watching. I wish you the very best of luck in your work, and I look forward to seeing you again next time.